right, thank you everyone. Welcome to my talk. My name is Hung-Yi Hu, and I am going to share some lessons and stories about how we secured internal applications at Dropbox. So a little bit about myself. I'm a security engineer. I currently lead the product security team at Dropbox, and my background in security is a little bit non-traditional. I studied computer science, but I also studied law and spent some parts of my professional career doing both. I definitely love to talk about both and where they intersect. So if you like to have those sorts of interesting conversations, definitely hit me up. Also, we are hiring on the security team. So if this kind of stuff interests you, definitely let us know. We'd love to hear from you. Now, I think of this talk a lot like doing a cooking show, in that I'm going to be sharing some recipes that work well for us, but this is not really meant to be a checklist. So instead, what I'd like you to help you do is adapt what you find useful from this talk and to hopefully help you solve your particular problems. And like a lot of cooking shows, I'm going to share some of our failures. So at least if you don't find this useful, hopefully it'll be entertaining. Some quick disclaimers. These are my views, not my employer's. And also, I did not do all this work. I had a lot of help with people on our security team as well as off our security team. But any particular mistakes here in this talk are mine alone. So let's start with a motivating example. So you might be wondering why we care at all about securing internal applications. Now, if your organization is like Dropbox, you might have applications internally that have sensitive data or provide sensitive functionality. So for example, here's two apps that I'll be referring to again and again in this talk. So you might have a debug panel, for example, that gives you access and control to some systems in production. Or you might have a business analytics app that's available to let business people on your business team query sensitive company data, right? So there's a whole big internet of evil out there. So you might say, well, that's really easy. All I can do is I can just firewall this off from the world and I'll just be done, right? Well, we work in security, so we know that, of course, a lot of people get this wrong, right? So you might accidentally leave a hole in your firewall. But even beyond that, there are issues that can often cause attackers to be able to cross web origin boundaries, right? And we'll talk about some of the ways that that can happen and what we can do to address that. And even beyond that, there might already be attackers inside your environment that you have to worry about, or there might be cases of internal abuse, right, that you have to worry about. And so these are all reasons why you might want to invest in hardening your internal applications. Now, I actually think that internal apps, securing internal apps is really interesting for really two, at least for us, for two reasons. For two particular challenges. So one challenge is one of scale. So unlike just the two example applications I showed you earlier, at Dropbox, we really have like order of hundreds of applications like that. And they really vary, they're of varying complexity. So some of them are a dashboard that someone hacked together really quickly, but some of them are much, much more complex. You can compare that with our external website, which is essentially, I'm simplifying a bit, but essentially it's one big web app. The second challenge that I think makes this interesting is that you have to deal with a really, really heterogeneous environment. And what I mean by that is that when you look at our external website, we have a pretty well-defined tech stack with a small number of technologies that are used. This tech stack is familiar to our engineers who typically are well-trained, and this is an area where the security team is familiar. We've spent a lot of time building defenses here. But if you look at our internal environment, it's a different story. There are potentially many disparate tech stacks, right? There are use of some frameworks, some of which might be good for security, some of which might not be so good for security. And these applications might be engineered by teams with different skill levels, right? So some of these applications might be owned by engineers that are well-trained, that run really reliable systems. But others might be constructed by someone who doesn't spend a lot of their time coding, right? And so with these two, and of course we also might have some applications where we don't even have any visibility into at all, which is not great. And so with these challenges, we really had two aspirations we're aiming for sort of as our North Star when we were embarking on this effort. The first aspiration we had was we wanted to build defenses that were scalable and as agnostic to the back-end technologies as possible, right? That's going to save us a lot of work if we can do that. The other thing that we wanted to do was to make sure that the process of developing these defenses and having teams adopt these defenses were also scalable. And now, of course, I call these aspirations because we didn't always succeed, and you'll see how that happened in this talk. But these, I think, are good North Stars to try to aim for, and you'll see the themes coming up again and again in this talk. Cool, so now I've talked a bit about the motivations and some of the challenges with dealing with internal application security. Now let's talk about how we can tackle some of the basics. So if we go back to our previous example here with our two our favorite web apps, let's keep in mind that, again, we're starting within our environment, so I just drew this sort of blue dotted line indicating our network boundary. But we're keeping in mind that we could potentially have hundreds of applications like this. So how do we scale up some of our security basics to all these hundreds of web apps really quickly? Let's suppose that we're starting from scratch. So the first thing that we could do is we could add a proxy, right, that takes in all the traffic between our users and relays them to these applications. And then once we do that, we can start doing things like enforcing TLS everywhere, right? This is good because that means that someone who's inside our environment is going to have a much harder time doing network interception introspection. We also we're going to want to add some network isolation. So this, and to make sure that people just can't hit these internal applications directly, right? So this might be a good idea because, for example, you might have a MySQL instance on your analytics web app that has, some interface, admin interface exposed on port 8000. We don't want a user to be hitting that be able to hit that directly. We want a user to always be able to access that web app through port 443, for example. So once we start building this proxy and adding some of these basic defenses, we can start adding all kinds of other defenses there. So for example, we can add authentication, right? We can add a standardized, strong implementation there that we control and we audit. So for example, we can add single sign-on. We can add really strong two-factor authentication that's phishing resistant. We can start adding basic access control, right? So we start checking permissions for all the requests that are going through. We can start enforcing that users have to use modern browsers. They have to be up to date. They have to support some of the security features that we need. We can add monitoring. We can add logging. We can add all kinds of different things. And so hopefully by now you're noticing that adopting this kind of approach provides some really nice benefits. One is that it provides a centralized, scalable place to build a lot of defenses into. And better yet, that means that the owners of these applications don't have to worry about building this stuff themselves, which is really awesome. And finally, it's really easy to deploy patches and changes. If you find a bug, there's only one place you have to deploy to, right? And that's a service that you have control over. And some of these benefits are also things that other security stakeholders might want. For example, your infrastructure security team or your incident response team, right? So this provides a lot of wins for everyone. It's a lot easier, I suspect, to try to push a project like this through. Now, of course, if you do this, there are some costs to doing this. There's some considerations you should be thinking about. But I do think that there's a really good return on investment here. But some of the things you might want to think about, you need an experienced team to own the maintenance and on-call of this. Your team might not have that experience, so this may be a place where you need to build a partnership with an infrastructure team, for example. But the good news is, as I mentioned, a lot of other teams might want these same benefits, so it might not be that hard for you to persuade them to do this. A related point is that reliability becomes really important, right? Ideally, if the proxy goes down, you want the system to fail closed, which means that you don't want these applications to be reachable. So if you have any critical systems behind that, now your proxy becomes a gating thing there. So again, if you don't have a lot of experience doing reliability engineering, this might be a place where you want to partner with a team that does have that experience. And it's also a really good learning opportunity. Also, something to consider when you're building this is think about what dependencies your proxy is going to have. For example, if you have a monitoring system for your proxy, and you put it behind your proxy, that means when your proxy goes down, you have no way of monitoring it. So those sorts of operational concerns are things that you want to be thinking about. Make developer testing and deployment easy. The easier you make it, the less friction there is, the more likely people are going to want to be doing this, and the less work there's going to be for your team in the long run. And finally, when you're rolling out any sort of security change like this, I recommend always prioritizing for the highest risk reduction. As you saw earlier, there are lots of apps that you potentially need to worry about. There's always going to be too much work. So you really need to be spending your time wisely here. Otherwise, it's just your life is going to be pretty miserable. Cool. So that's a little bit of how you can get started building a really scalable, centralized framework to start building defenses into. So now what I'm going to do is I'm going to talk about some additional defenses that we can add on top of this framework. And I'm going to illustrate it with a bunch of concrete stories. And the first story I want to talk about is handling cross-site request forgery. Now, if you're not familiar with cross-site request forgery, or you're not sure why it might apply in this context, here's a motivating example. So we go back to our two web apps, and we can imagine that some of them might have sensitive state-changing functionality, right? Like you might be able to delete a table in our analytics app. Or worse yet, there might be a kill switch in our debug panel, right? That could take down some systems in prod. So it'd be really bad if an attacker would be able to trick a user into making these same requests. Well, that's exactly what happens with a cross-site request forgery attack. Right? So a user might get tricked and go to evil.com. Evil.com sends back a malicious web page, and that malicious web page gets the user's browser to make these requests on behalf of the user. So normally, CSRF protection is handled by the application itself, or if you're using a really good framework, the framework might be handling it automatically for you. But again, we're dealing with an environment where we have all these different random technologies. Right? We can't assume that this is going on, and we actually probably should assume the opposite. Right? So the problem is we need a way to scale our CSRF protection to this environment. So one thing that you can try, and this is what we did, is to leverage a new technology called same-site cookies. And the idea is pretty simple. So if you're not familiar with it, it's essentially a cookie flag that tells your browser, only send this cookie on same-site requests. So for example, if I'm interacting with my debug panel directly, my same-site cookie will be sent. But if I'm dealing with a attacker website or some third-party website, and that attacker's page is trying to tell my browser to make these requests to this debug panel application, that same-site cookie is not going to be sent. Now, I'm simplifying things a little bit. The actual behavior is a bit more complicated. You can read about it offline, but that's the general idea that you need to understand for this talk. Now, you might know that this feature is only supported right now in a few web browsers. So there's Chrome, there's Firefox. I think there's Edge support for this. So this is not necessarily a comprehensive defense if you're worried about browser compatibility, like if you're worrying about this for an external website. But fortunately, we have an advantage here. We control the environment internally, right? We can set some policies for our internal users. We don't necessarily care about browser compatibility when we're talking about internal apps. So what we can do is we can have our browser, as I mentioned earlier, enforce that you're using certain browsers, or your proxy be enforcing that your users use certain browsers, right? They have to be up to date. They have to be supporting this feature. And so this is a good idea you should be doing anyway, and we can leverage this fact. So how can we apply this idea in this context? Well, we go back to this example again. What we can do is we can have our proxy set a new same-site cookie. We will have it in same-site strict mode, which means that this cookie never gets sent on a cross-site request. And what this does is this tells the browser now when a request is cross-site and when it's not. Now, one thing to keep in mind when you do this is make sure this is a different cookie than your session cookie. Absolutely do that. If you make it your session cookie, your website will probably break. Hopefully, if you take a minute to think about it, you'll understand why. It's because that session cookie means that their session cookie is never going to be sent on all requests. There are going to be some requests where it's slowly going to fail. Sometimes you'll be logged in, sometimes you won't be. So take it from me, please make it a separate cookie. So now once we have this bit of information, we want the proxy to be able to make a decision. Should I allow this cross-site request or not? And the way we can do this is we can leverage another idea. So we can build a policy for each of our applications internally. And then we can enforce that policy at the proxy level. So for example, a policy might look like this. So for our debug application, maybe going to that top level page is totally fine, right? So we'll always allow that from a third-party website. But maybe going to that kill switch route that I talked about earlier is not okay, so we're going to 403 there. This policy can be really flexible. It can be as coarse as you want to. It can be as fine-grained as you want to. And so we rolled this out internally and found that it worked really, really well for us. And there wasn't a lot of work invested. It's really powerful and flexible, as I mentioned. In order to build this policy, it wasn't that much work because we could analyze our logs and build it automatically. And you can start with something really simple and coarse, and then you can do as much work as you want to or as a little work as you want to, depending on what you feel like your risks are. Eventually, if you get really fine-grained, you're going down this rabbit hole of that leads to an idea called entry point regulation, right? This is sort of a simpler version of that idea. And if you'd like to read more, I would recommend that you read about that offline. But that's where we got this idea from. Finally, if you're going to roll this out, please help out your developers. We definitely made a lot of mistakes as we were building a lot of these defenses. So whenever you implement blocking, make sure you have some error messaging that tells your developers how to get help. Right? It's going to make your relationship work that much, much better. All right, so that was a concrete example of how we had built CSRF protection on top of our proxy framework. So now I'm going to tell you a slightly less, or perhaps a moderately less successful story, which is how we dealt with handling security risk from scripts. So going back to our motivating example, let's go back to our analytics web app again. We know that web apps can be vulnerable to cross-site scripting attacks. So for example, there might be a reflected XSS attack against our analytics application. So that's something we obviously need to worry about. But also, there's another problem. We don't necessarily know what scripts our hundreds of different types of web applications are necessarily loading. They might be outdated, but they might be vulnerable, but they also might be downright malicious. We just don't know. So for example, your web app might be using a CDN and loading jQuery, right, directly from there. And so what might happen is that an attacker could take over that CDN and start serving a malicious version of jQuery. That would also be really, really bad. And of course, you might know this has happened before, right? CDNs have been compromised, leading to website compromise. So here's an example from the Wall Street Journal from a few years ago. But also, your developers might not be using a legitimate CDN, right? They might just be deciding that, hey, I found this cool script on GitHub. I just want to use it directly. And so they might use a service called rawgit, which just does this for them. And so if you're a security person, this might not be what you want. So how do we want to deal with this? So here we can leverage a technology called content security policy. And if you've been to some of our other talks, you might know that we're big fans of it at Dropbox. And if you're not familiar with it, what it is, it's a mechanism that lets you tell the browser, hey, these are the content sources that you're allowed to load on my web page. Anything else you should just block. We had a lot of success rolling it out externally on our website, and so we wanted to apply the same strategy here. Now, you might know that this actually is not an ideal solution. You might know that having a robust defense for cross-site scripting requires really a lot more, right? You want a framework that constructs your HTML for you safely, that automatically escapes untrusted data. You want to use a good DOM sanitizer. You can deploy CSP on top of that, right? So CSP by itself, it's a mitigation. It's not going to solve all of your problems. It's something important to really keep in mind. Now, one problem we have is that we don't live in an ideal world, right? We have a bunch of legacy apps that some people have already built over time, and so they don't have these safe constructs built in automatically. It's going to take time to migrate all of these applications, right? So in the meantime, we do need to do something, and so one thing we can do is we can roll out CSP as a mitigation for these legacy apps. The other thing I was going to mention was you might be familiar with a technology called sub-resource integrity. And you can identify correctly like that is also something that you should be doing for the CDN problem. And that is something we should do, and we absolutely do as well. But unfortunately, right now, there isn't a great way of enforcing that a website uses SRI. As far as I know, there is a directive in content security policy, but it's currently only enabled behind a experimental flag in Chrome. So we can't quite rely on that yet. We sort of have to just declare that people should be doing this and hope that they follow what guidance we give them. Cool. So that's a little bit of introduction into content security policy. So if we're going to roll it out, we need to make sure that what we're rolling out is effective. And one common way of rolling out CSP is to implement what's called a whitelist, or I'll call that an allow list of content sources, right? We're just listing the different places where we can load content from. Now, it turns out that a lot of websites actually get this wrong. And there's this great Google paper from a couple years ago that I recommend you read if you haven't, that showed that a lot of websites, what they do is they have a list that's really broad. So it allows, potentially allows loading of way more sources than perhaps the owners of these websites intend. And what that means is that it leads to a lot of policies that are actually fairly easily bypassable, meaning that the actual security benefit is really very limited. So to deal with this problem, we're actually going to roll out two policies. And the way this works is that when a browser sees that a website has two content security policies, it's actually going to require that any piece of content pass both of them, right? So it's going to be essentially a logical AND operator, right? So if a piece of content only passes one policy but not the other, it's not going to be allowed. It's going to be blocked. And so what we're doing here is we have one policy. The first one is an allow list. It just simply lists, the sources that we can load from. And what this does is this provides some visibility and management for us, right? So before we didn't know what sources we were loading from. Now we have a way of tracking that, right? Because this can be stored in a configuration file that we can audit later, do code reviews on, and so forth. The second CSP is actually what provides what actually does the security heavy lifting. And the way this works is this requires what's called a nonce. Right? So every time you put a script in your web page, there's a script tag, and you need to include this random nonce in there. And so what this means is that you actually have to individually permit specific scripts, right? So you can't just permit a broad swath the way that you can do in an allow list. You actually have to individually permit specific scripts. And so what happens is you have this sort of broad policy in CSP1, and then we have a much, much tighter policy in CSP2. And when you combine the two together, you have a pretty robust defense. So here's what this implementation looks like. So we can have our proxy inject our CSP headers in all the outgoing requests, outgoing responses. And then we can also have it generate our nonces and inject these and provide these nonces to the backend applications using some custom HTTP header. And of course, as I mentioned earlier, we can define our policies in these configuration files. We can have application owners own these configuration files, and we can do code review. That way, we have a process where we're not doing all the work, and it makes it that much easier for our team. And finally, we can follow best practices. So we'll roll this out in report-only mode. We'll get a bunch of reports, and then we can use those reports to refine our policies over time and eventually put this out in enforcement mode. So this all sounded like a great plan. It sounded like we had experience doing this before. This is no problem. We're just going to hit the win button. We'll just be done. Now, if you've ever rolled out CSP before, it shouldn't surprise you, should not shock you that this was not that easy. We definitely ran into a lot of challenges doing this, and we're still definitely we're in the process of making this happen. Now, one of the main challenges that we ran into was that a lot of legacy applications and third-party applications use inline code. And in some places, they needed to use eval. And so what this meant was that we had to do a bunch of manual work to make those applications put nonces in the right places, which really sucked for us. The right way to handle this is eventually you just want to never use inline code. It's just much better for a number of other engineering reasons, but it's a lot of work. And there are some tricks you can do to automatically transform inline code into non-inline code. You can read our blog post to see some techniques you can do that, but still it's going to be a bunch of work for you. And what's particularly annoying is that there are many third-party applications don't support CSP very well, and so they require inline everywhere, and it's just a mess. Now, the second challenge we ran into was that self-serve adoption was actually really hard. And that's because CSP was really hard for developers to understand. This is even after we invested significant efforts to write documentation for them, to explain the requirements, to explain what we were trying to do, why we were doing this. And this is even after we built some safe ways for developers to test it and roll it out. And here are some of the common complaints that we would get. So one common complaint was that we'd get asked, hey, why can't I just do an allow list? because developers really did, it was hard for them to understand the nuances of what nonces did and what could go wrong with an allow list and why, what kind of security benefit you would get from doing that. It was just really hard for them to add that in a lot of cases. A second complaint that we sometimes get is that, hey, CSP broke my app, which was often wrong because we'd only rolled it out in report-only mode. But what it turned out was that developers just didn't understand what was going on, right? They'd see all these messages, error messages pop up in their console, and they didn't know how to interpret them. And finally, here's more of a one-off example that happened outside our proxy environment, but this illustrates my point. There was a developer that wanted to roll out CSP. And so what he did was he typoed the header. Then he constructed his policy. He tested it in the browser. He saw no violation, so he thought everything was fine. And of course, what happened was the browser doesn't know what content secure policy is. It knows what content security policy is. And so if it sees content secure policy, it just doesn't do anything. And so of course, you're not going to see any violations. Now, my point here is that it's not that developers are dumb. It's just that CSP is really hard for them to understand. And a lot of this, and hard for them to deploy in a safe way, in a secure way. And really, a lot of this is on us as an industry. We haven't really made it, made ways to make these defenses easier to adopt. And it's really unfortunate. And I think this is something that we should aspire to when we're trying to design these sorts of defenses in the future. But hopefully by now, you see that using blessed frameworks really is the way to go. It's frameworks, what I mean here is I mean frameworks that add in defenses, have them built in by default, they're turned on by default, so that developers don't have to think about them. It's a huge return on investment. We do this externally on our external website. So for example, our tech stack externally adds in nonces for developers. They don't even have to think about it. Right? So in that situation, it's much, much easier for them. And in retrospect, it probably wasn't surprising that when we had to get them to take this extra step of thinking about nonces, it became that much more difficult. So if at all possible, invest in this. This is going to help you a lot in the long run. But in the meantime, unfortunately, there's going to be some work related to dealing with legacy apps. So to wrap up here, if you are considering rolling out CSP, some things you should think about, and I encourage you to consider whether it makes sense for you. But some things to think about. Definitely prioritize reducing mental burden on developers, right? As you saw, I think earlier, it's very important that you make it as easy as possible. Otherwise, you're just not going to get very far. So invest in blessed frameworks. Auto-generate their policies for them, right? Write scripts to do it for them to take that burden away, make testing and debugging trivial, and also make deployment and rollback safe and fast. You're probably going to spend more time than you expect refining policies, and you're going to make mistakes. So invest in reversing those mistakes, making it easy and fast to reverse those mistakes. Also, brutally prioritize for risk reduction. In a lot of cases, I suspect, you might actually not need CSP, right? For some applications, the risk just isn't there, and so it's not worth the effort of rolling it out. Other mitigations might be totally fine for your needs. Expect challenges as you're doing this. So if you have any trusted partners, I highly recommend that you experiment there first. It lets you move quickly. It lets you, it reduces the cost of failure, and then you can see what works and what doesn't. And then you can start working with the rest of your organization. And finally, third-party open source apps continue to be a problem. There really aren't a whole lot out there that we've seen that are friendly for CSP. So if you're interested in upstreaming support for this, definitely talk to us. This is something that we're thinking about investing in as well that will help hopefully improve the community here. Cool. So that was a story about how we rolled out CSP. So now let me tell you a story about how we added detection and response on top of all the basics and some of the more specific defenses I just covered. So just to remind you, these are some of the attackers that we might be worried about and some of the things that we might want to know what's happening in our environment. So for example, there might be an attacker that gets past our defenses, finds some way of hitting our internal services. Or there might be an attacker already inside our environment, or there might be a case of internal abuse. So what are we going to do here? Now, I am going to give perhaps a somewhat surprising recommendation. which is that I'm going to recommend that you consider using a WAF. And I'm going to say that I think in the external context, WAFs do have some shortcomings when it comes to detection and blocking. And there are really two reasons for this. So in the detection case, we know we're on the internet. We know that there are bad people on the internet, so we know that attacks are happening against us all the time. Specifically, the base rate of attacks is really, really high. So I just don't know what to do with that information. What I really want to know is whether an attack actually succeeded or not, because then I can go and fix that, find out if there's a bug, I can fix that bug and so on. But it's really hard with the state of technology today. And then in the blocking case, one of the issues is that WAFs just aren't perfect. So they're bypassable. That means attackers can try again and again and again, and they're going to get through at some point. But in the internal case, we should have a different hypothesis, right? So we should be on the network of nice things. We're not on the internet of evil anymore. So it's a happy place with puppies and sunshine and rainbows, right? And all kinds of cute things. And so our hypothesis here when we started was that this should be a lot more promising for anomaly detection, right? Because the base rate of attack should be really, really low. If it's not, it means we're either in the Beyond Corp world, either intentionally, perhaps unintentionally, right? And also, it's more useful for blocking, because as soon as we see something, it's probably high signal that something bad is happening, so we can get our incident response team to take it down immediately, right? Whereas the cost of blocking externally is potentially a lot higher. We might be blocking a lot of potential users. So as we're trying to design a detection system and trying to configure a WAF to be useful for this, it's very important to make sure that you're getting the false positive rate to a manageable level here. And the reason for that is something called the base rate fallacy. And if you're not familiar with this idea, there's a great paper that I put on the slide that I recommend that you read that talks about how this applies in the intrusion detection context. But what I'm going to do is I'm going to go through an example so you understand what I'm talking about. So let's imagine that you have 100,000 web requests in your environment every day. This is probably like a pretty low number, but let's just go with that. And let's say every day that 10 of them are malicious. Again, this is probably way too high, but you sort of get the idea. Like realistically, you're not being attacked all the time internally. So let's say that we have a detection system that has a false positive rate of about 1%. And a false negative rate of 0, right? Meaning that it's going to catch everything that's bad. So it's going to catch all 10 of these bad requests every day. But some number of not bad requests are going to get flagged, right, as false positives. So you might think this sounds like a great detection system. It's going to catch everything. I'm only going to get a 1% false positive rate. That sounds great. But if you do the math, it actually turns out that you are going to get those 10, for your alerts, you're going to get those 10 true positives that are actually bad. But you're actually going to get like 1,000 false positives. So if you look at this, it's basically saying that for every alert that you get from your detection system, 99% of them are going to be false positives. You're going to spend all your time chasing down things that you don't need to chase down. And it's going to take up a lot of your time. And the reason that this is an issue is because here your base rate, right, the number of actual attacks that happen is much, much, much lower than your false positive rate, right? So this is something that you really need to keep in mind when you're designing a detection system, because that was going to significantly limit its usefulness. So what we did here was we deployed a WAF. We started out in non-blocking mode. We observed false positives. We add those to a filter. We'd rinse and to filter them out. We'd rinse and repeat. And over time, we get more confidence. We move it to enforcement mode. We'd have these large alerting and blocking thresholds. We ratchet it down over time. And turned out there are a lot of places where there are false positives. And so here are some of the most common ones that you see, right? Analytics apps that take in input that looks like SQL, turns out looks a lot like SQL injection to a WAF, right? Or like a code search application, might look like directory traversal, things like that. And so there are a lot of places where there are issues here, but it turned out it wasn't too much work to filter these out. And eventually, we were able to get to a place where we had a pretty low false negative rate, or a false positive rate, one that we were pretty comfortable with. And we were able to catch some real scenario or real activity inside our environment as well. For example, we were able to detect internal pen testing activity. Of course, we're not going to catch everything. We know that we're not going to catch potentially really stealthy attacks, but the idea is that we might catch some sign that something bad is happening here. And so here's an example of something that happened to us. So one day we get this alert that says, hey, this looks like an XSS payload. Of course, I see this and think, either someone is trolling me, or like there's a script kiddie that got inside, or like something is going on here. So I check with my team because sometimes they like to be testing things internally. No one's testing anything right now. I know there are no pen tests going on, so now I'm starting to get worried. Right? This is starting to look kind of sketchy. So I contact someone on our incident response team, and we start digging, and eventually we get to this dashboard with a bunch of graphs on it. And if you find the problem, like if you found the problem immediately, I'll say that you did way better than we did because it took me like a few minutes of scouring the page but I finally found this. And if you're wondering what happened here, it turns out that we had a pen tester come in a few months back that left a gift for us, a gift that he forgot to clean up, a gift that did not manifest until many months down the line. And so why am I telling you this story? I'm telling the stories because in addition to building a detection system, you also want to make sure that you have all the supporting scaffolding behind it. So for example, your team probably isn't the team responsible for internal detection and response. So you probably want to make sure you're partnering with that team. And you want to make sure that you have a process for handing off those investigations to that team, right? So that it goes smoothly. Also, you want to make sure you have thorough logs for your investigations. Don't necessarily just rely on your WAF logs. Make sure you have logs everywhere. Logging is pretty cheap, so you're going to always be, I don't think you're ever going to be sad that you had more logs. You're typically sad that you didn't have the logs that you needed. And here, we would not have been able to find the problem as quickly as we did without all the additional logs that we had. And finally, of course, be aware of base rate fallacy as you're designing your detection system. A lot of ideas might seem great, but then it turns out that your false positive rate might just be too high. And of course, make sure your pen testers clean up after themselves. That always helps. One bonus story I'm going to share with you is with content security policy. So when you roll out content security policy externally, one thing that is commonly told is that you should immediately filter out a lot of useless reports. So here's an example from our blog. By the way, shout outs to Neil Matatal, who wrote about this back in 2013. He started a list like this that we sort of cribbed from. And the reason that you want to filter these out is because a lot of these are due to people having malicious browser extensions and malware and things like that. And there's not a whole lot that we can do in the external context. But internally, this is kind of stuff that you want to know about, right? If you see a hit to superfish.com, if you see a violation report relating to that, that probably means there's something bad going on and someone needs to do something about it. So I actually think that there's a lot of potential here to use internal CSP logs as a detection tool. So something to consider. All right, so I took you through this journey where I showed you how we built a platform. I showed you how we were able to build specific defenses on that platform. I showed you how we did some detection and response capabilities on that platform. So now we know that there's a lot more that we can do here, that I didn't cover. So how do we tie all of this together into a more coherent strategy? And here, I actually think a really good place to start is the cybersecurity framework from NIST. Now, I happen to be one of those people that is allergic to anything with cyber tacked on the front of its name. I'm kind of like one of those crypto means cryptography people, but even more hipster. But we actually found the NIST cybersecurity framework to be really useful as a modeling device. So don't be put off by the name. Now, normally I would tell you, if you want to read more, go to the website. And I tried to grab some material for this talk from their website as well and got foiled. So you're going to have to make do with my rudimentary graphic design skills here. But basically, it kind of looks like this. So NIST divides a security program into 5 main security functions, right? Identifying your assets, identifying your risks, protecting against those risks, detecting and responding to attacks, recovering from those attacks, et cetera. So today, for example, I talked about some things that you can do in the protect, detect, and response space. But there are obviously a lot more functions that you might need in a more comprehensive program and a more comprehensive strategy. So what I recommend, and again, these are my simplifications and adaptations. It's not meant to be is something that you need to do. But I highly encourage you to at least start with this and start thinking about, as you're filling out this table, who are the people, who are the teams that you need to involve in your program? What's the tech that you have to build? What are the processes that you should create? This is going to help you figure out where your gaps are, where you need to invest. And you can see this can easily become your roadmap, right? This is also a really great way of communicating your strategy to senior management. And I actually borrowed some ideas from Adam Shostak here. He has a great analogy of describing this as a security investment portfolio, where you can kind of see where you're investing and where you might want to change those allocations. And like I said, it's a really great way to communicate what your strategy is so that in a way that management can really understand it. This is a really simple tool, but it's really flexible, and you can really adapt it as you need to. So some final thoughts here. Always aim to scale your defenses and your processes. I think this is just true in general of security, not just internal AppSec, but it's particularly relevant for us. I also think this is a great place to experiment and to train up new engineers, right? So for example, if you're not sure about CSP, you're not sure about same-site cookies, well, you can roll that out internally first, right? The risk is a lot lower, the stakes for failure is a lot lower, and it's okay. But you're gonna learn a lot, and then you'll learn whether or not it makes sense for you to roll it out externally, and you'll have a lot more confidence. Also with new engineers, if you haven't invested in internal application security before, it means that there are opportunities to build things from scratch, and I think that's a great way to learn. In fact, we trained up someone who transferred to our team by having him work on internal AppSec. Finally, these are just our experiences. So please share yours if you have anything that you think is useful or helpful for other people. We'd love to hear from you. And finally, there are many other ideas that I didn't talk about here, so we're really just scratching the surface. So if you want to talk about any of these ideas or others I haven't mentioned, hit me up offline. I'd love to chat. And that is it for my talk. I'm happy to take any questions. Thank you for listening. Right, so with tokens, we obviously use tokens on our external website. One of the things that we had to worry about was because we had all these different applications, if we wanted to scale that approach, it was going to be more difficult because we essentially needed a way to automatically inject these tokens and have these applications and automatically inject these tokens in the right requests. And that seemed much more difficult than our cookie approach, because that's something that the proxy can easily set and read. Does that make sense? So it's not like, I'm not saying that it's necessarily better, but rather it's more of it fit better with our strategy. It was a lot easier for us implementationally. But yeah, we definitely use the same approach externally. We use CSRF tokens. And also, of course, there's the browser compatibility issue too. Yeah. Yeah, so if I understand the question, I think what you're asking is, have we thought about putting WAFs in many more places because it might be a high confidence signal that a breach might have occurred in a particular area? Yeah, I think essentially. Okay. So we're definitely still in like the early experimental stages. Like this is something that we thought we'd try. We rolled it out and it turned out to work pretty well. I would say that it's something that we would potentially consider, but given how like our internal network is like architectured, like we essentially have put it in places that we really, really care about. And like there are other places that are less risky that we could also add WAFs, and we might in the future. But yeah, we're still sort of in the starting stages of this. Yeah. Cool. Any other questions? All right. Thank you.